and talk about it a little bit. And this week you may have a big homework assignment. I want to get it in soon because I know it happens at the end of the semester, and that is you start to focus on Japanese and you stop focusing on anything else. I've been here for 8 years, so I know what happens. So, anyway, you can see that, right? Okay, so let's take anyway, so you might have a big homework assignment this week, so don't plan too many parties, or whatever else. Don't plan too many anything else. All right, let's look at this. Assignments. I have to do review. Okay, let's see. Limits graphically. Okay. So maybe it's a good idea for me just to explain what I think when I think of limits. So we talked just a little bit last time we met, I think, about this, but I'll just review it because I don't remember exactly what we said. So suppose you have this function here. Okay, suppose you have this function. Okay? And I think we did this last time, or anyway, I'll ask you, like for example, suppose I said, what's f of 0? So that's easy to do. Is the light on? Is the light good enough here, or do I need more light? Okay, what's f of 0? That means you put 0 in there, so what do you get? 4 over, negative 4 over negative 2. So you get 2, right? This is equal to 2. Suppose I ask you, what's f of 1? What do? You 1 squared minus 4, or 1 minus 2, right? So what do you get? Negative 3 over 1. And negative 3 over negative 1. Right, so what's that? 3. Okay, so you can do that. But suppose we set, and of course you can do this one also. What's that? So you get 9 minus 4, and you get 3 minus 2, so that's 5 over 1, right? Right? 9 minus 4 over 3 minus 2, so you get 5. Okay, so you can do that also. But suppose we asked, what is this? So what's the answer to that? So there you put 2 in the top and 2 in the bottom. What do you get? 0 on the top and 0 on the bottom. And that's famously undefined. Right? We say that can't do that. That doesn't mean anything. Right? So you don't have any answer for 2. In other words, we say that you can't put 2 into that function. That's what we usually say. So you're not allowed to put 2 into that function. Okay, but otherwise you can put all these other values in. And we also often say this, right? Right? And then we often do this so that we get this. And when we say that, we mean, when we say this side equals this side, we mean that they're equal for every possible value of x. So let's check. How about for 0? We already know that on the right side we get 2. How about if we put it in here? We also get 2. How about for 1? We already know on the right side we get 3. How about if we put it in here? We also get 3. So for every value they should be the same. That's what we mean by saying that they're equal. Okay? So the question, but this one doesn't have any issue or problem when x equals 2, right? This one is equal to 4, but this one we're not allowed to put 2 in. So what I just said is that they're the same everywhere except at x equals 2. So if you want to graph the one on the right, you can just graph the one on the left instead. And then it's easier to graph it, right? Because everybody knows what this looks like. This is just this like that, right? Everybody knows what that looks like. It's just a straight line that has a y-intercept of 2 and a slope of 1. So here's 2, so it looks like that. So now it made it very easy to graph this function. Okay? Made it very easy to graph that function. Now the only thing I have to make sure of is that it's not really the same everywhere. It's the same everywhere except when x equals 2. So I just have to somehow indicate that. And the way that I do that, usually, by putting a circle at 2. But everywhere else, it's equal. Okay? Except for that. Okay, now, if I told you, oh, I have a function in my back pocket, or I'm talking about a function, and then you say, oh, please tell me the value at 2. And I'll say, I'm talking about this function, but you don't know what it is, just hiding this function. But you ask me, please tell me the value at 2, what would I say? I'd report back to you, oh, it's not defined at 2. And then, okay, you'd say, okay, not defined at 2. But, you know, I could give you a lot more information than that. Even though it's not defined at 2, there's a very obvious pattern near 2. And if I just tell you it's not defined at 2, I'm sort of not giving you all that extra information. So the idea is, it could be useful to be given that extra information. And the extra information I mean is that even though it's not defined at 2, as we get closer and closer to 2, from either side, so here, let's say this is 1. So at 1, what do I get? What's the function at 1? It's 3, right? So, okay, 3. But as I get closer and closer to 2, yeah, I agree it's not defined at 2, but if I just told you that, I'm not really, I could tell you more than that. What I mean by that is I could say, as you get closer and closer to 2, the height is getting closer and closer to what? 4. Okay? And also, it's also true coming from this side as well as this side. Right? You understand? So if I want to be generous, if you want to be informative to somebody else, you could say, yeah, okay, it's not defined at 2, but as you get closer and closer to 2, it is getting closer and closer to 4. And that is the use of the concept of limit. The limit expresses that fact. The limit said, what we say is the limit as you get closer to 2 is 4. So that's like reporting a little extra information to another person. Okay? And the way we write that is the limit, and what was our original function, by the way? Not just this one, but that one. So that's how we write all of that. So it looks very complicated and confusing and messy, but all it means is what? It's getting close, the height is getting closer and closer to what? What is it getting closer and closer to? 4, so we say that this is equal to 4. So this is where we say x is getting closer to 2, the height is getting closer and closer to 4. Okay, and that's just an expression, that's the way they express. You know, somebody came up with this notation 300 years ago, maybe. So that's what people have been using ever since. But the fact of what it's expressing is just what I just told you. Okay, is that clear? So how about if I changed it to 3? So that's saying what's happening as x gets closer and closer to 3. So that means like here's 3. So as you get closer and closer to 3, as x gets closer and closer to 3, what does the height get closer and closer to? Well, to do it easily, you can use this formula. So what is the answer? 5, right? So we would express that like this. Okay? So you might say, well, who needs that? You know, that's kind of, I mean, obviously, when x is equal to 3, it's equal to 5. So why do I have to say what's getting closer and closer? Yeah, in this case, you don't really need it. It's kind of extra or redundant information. But in this case, it was useful. Because in this case, what did we say? It was not defined at 2. In the other case, when I said 3, it is defined at 3. So it's kind of useless. It's like not really important, not really necessary to say what's happening as you get closer and closer to 3, because it's even defined at 3. But in this case, with 2, it wasn't defined at 2. So you just have to say, oh, it's not defined. That doesn't, you know, if I just tell you what's not defined, I'm not giving you this whole pattern that's happening. Okay, is that clear? Does this make some sense? Okay, so this is the notation. You put the function in here, and you put the value that x is getting closer to, and then you ask, what's the height getting closer and closer to? So let's take another picture where we don't have the formula like we had here. Here we have the formula. Suppose I just give you the picture and ask you for it to do the answer. So suppose I give you this. Something like that. And suppose I tell you here, let's say at 5, it's equal to 10. And I put that like that. So what would you say, and suppose this function is called f. So if I ask you, what is f of 5, what's the answer? What do I mean by drawing the circle here? What's my point of drawing that circle there? I'm trying to indicate, that's our way of indicating that it's not defined here. We need some way to indicate that it's not defined here. This is what we do. Okay? So that means it's not defined. So you'd have to say not defined. Okay? But can we give a little extra information? Besides just telling somebody it's not defined, what else can we say? You put the function here, so this is where the function goes. So I'll put the function, all I know is it's called f, so I'll just call it f. Put that there, and then the place where you're interested in, the x value that you're interested in, you put down here. So what's the x value that we're interested in here? 5. And what's the answer to this? It means what is it getting closer and closer to? Now, remember when I say what is it, if you're looking at the graph of it, it means the height. So when I say what is it getting closer and closer to, or what is the function getting closer and closer to, if you're looking at the picture of it, that means what's the height getting closer and closer to. So what is the height getting closer and closer to? So if I choose this value, the height is going to be here. If I choose this value, the height is going to be here. If I choose this value, the height is going to be here. If I choose this value, the height is going to be here. If I choose this value, the height is going to be here. So as you get closer and closer to 5, what is the height getting closer and closer to? 10, right? So that's what you write here. That's how we express that fact. Okay, does this make sense? Okay, and we read it like this. The limit of f as x gets closer to 5, or they say as x approaches 5, is 10. That's what this means. Okay, so that's a concept that turns out it's a kind of a tool that we use to look at functions with. Like a microscope, you might look at, a microscope is a kind of tool that you use to look at different things, and this is a kind of a tool that we use to discuss functions. Now, suppose I had this function. No, let me just change this. Suppose I have the same function, and I had this. Now, is that really a function, this picture? So I called it a function, but am I wrong in calling it a function, or am I okay to call it a function? So the rule for whether something is a function or not is if you put in a value for x, you're only allowed to get one answer for y. So this is not a function, because if I put in this value for x, I get that height and that height. That's two different values I could get. That's not called a function. It's called something else. It's called a relation, but it's not called a function. A function restricts that you only get one thing out. When you put x in, you can't get two different values. Okay, that's just the rule for the definition of a function. Okay? So, for some reason, somebody wanted to define something like that, and so that's what a function is. So anyway, so is this a function? I used the word, let's talk about this function, but before I talk about it, let's first agree that it actually is a function. So is it a function? Yeah, because there's no place where you put in an x and you get two values for y. Now, if the graph looked like this, if it looked like that, is that a function? No, because then, if you put 5 in, you get 10, say, and also 15. That's not a function. You're not allowed to do that. That's not called a function. But let's suppose we had this picture. So it is a function. Okay, now remember I said that the usefulness of a limit is when you have an undefined place. Right? Like over here. I said, I could just say, oh, it's not defined at 2, but I'd like to give you some more information. So I tell you about the limit as well. It's kind of hot in here, isn't it? Is there any cooler? Or they don't have coolers yet? No coolers yet? Maybe I don't think we get that yet. How about open windows? That'll work. Anybody want to open your window? You can. Okay, let's see. So how about this case? Now, is f defined at 5 or not? Does f of 5 exist or not? Yeah, it does, right? What is the answer? 15. So it is defined. But obviously this is kind of a weird function, right? Kind of looks weird, right? But still, maybe there's some case where this might actually occur in the world. I don't know what it would be an example of, but it might. So, anyway, how about this? So f of 5 is what again? F of 5 is what again? 15. But what about the limit as x gets closer to 5? Is that also 15 or not? It's not 15. right? As you get closer and closer to 5, so you see there's a difference between at 5 and closer to 5. There's a difference. Those questions mean, they want them to have different meanings. Okay, we want to have one question which tells you what's happening at 5, and we want another question which tells you what's happening just near 5, so to speak, near 5. So what about near 5? What's happening? It's getting closer and closer to what height? 10. Everyone get that? So this is 10. Okay, is that clear or not clear? Okay, so that's what we mean by limit. Okay, now one more case. And that is, so you might say, why are we studying this? We need it for the next concept. So, how about this? How about if we had a function like that, and like that? And let's call, okay, let's say 5. And let's say this is 10 and 20. Okay, first, and let's call this G. So first of all, I could ask, what is G of 5? First of all, is G of 5 defined or not? Yes or no? Yes, it is. What is the value of it? It means the height of the graph. 20, right? Okay, now, the next question doesn't work. The next question is this. This question doesn't work. Why do you think I want to say it doesn't work? The question would be, as you get closer to 5, what's the height getting closer and closer to? But the thing is, when we say limit, you're not allowed to give two values. That's one of the rules on the definition of a limit. You're not allowed to say, oh, it's 7 and 10. No, you can't do that. You have to be able to identify a single value. That's part of the definition of the limit. So what? This doesn't work. Why not? Yeah. What? Well, we can't have two limits. So we say there is no limit. And why is that? Because if you come closer and closer here, what would you guess the height would be? 10. But if you get closer and closer from the right-hand side, what would you guess the height would be? 20. So, but in order for to set, this is part of the definition of limit, is they have to be the same thing. And they're not the same thing here. So we say in that case, this one, they use this, D-N-E. What does that stand for? D-N-E? Does not exist. Okay? Doesn't exist. That limit doesn't exist. Okay, do you understand? However, they say, okay, well, again, they say, well, it's a little bit of a pity just to say, oh, it doesn't exist, because there's certainly some patterns that we could explain to somebody else. But why just say, oh, it doesn't exist? So they say, how about if we make this statement? Well, before I write it, let me write it like this. You read that? What does it say? The limit, this says, as x gets close to 5 from the right, just from the right, in other words, just from the right. So if you're only coming in from the right, what would you say the limit was in that case? 20, right? Right? Okay? So we write, this is G, right? So what should I write there? 20. Okay, now they don't write out all those words, so please watch this because otherwise you'll be confused. So, okay, first of all, does everybody understand that statement? Okay, what does it say one more time? Oh, by the way, sometimes we write limit and sometimes we just write lim. Doesn't, just a shorthand. Okay? So lim or limit. If you want to write limit, limit. Okay, so what does it say? The limit as x gets closer and closer to 5 from the right is what? 20. Okay? All right, let's do one more. The limit as x gets close, or closer and closer if you want, close to 5 from the left, I should do G. And what's the answer to this one going to be? What? 10, right? Everyone agree? 10. Okay, now you can imagine that we don't want to write all that out, right? That's too much to write every time, right? So they have a difference, they just make a symbol for this. So the symbol is a little confusing, so that's why I wrote it out the first time. So instead of writing it like that, they write it like this. And to write, and the way they express coming in from the right-hand side is by putting a plus up there. I don't know, somebody made up that notation. I don't like that notation at all, but that's the notation that they use. So all that means is what? When you're getting closer and closer to 5 from the right-hand side. Okay, that's all it means. It just means these words. Okay, and this one, maybe you might guess how we're going to express this one, or maybe you won't. Okay, this one is going to be that. Okay, so whether you like that notation or not, that's the notation they use. Okay, and I don't like it, but that's the notation they use. So this means this, so this is equal to 10. And this means this, so this is equal to 20. Okay? Is this clear? And if we don't have any symbol there, if we just said this, then what was the answer to this one again? Doesn't exist. Does not exist. Okay, because if it exists, they have to be the same. Okay, now let's go back to this one. This is the one we started with. First of all, let's call this function f. So first I'll ask you, what's f of 2? What's f of 2? Remember the function was x squared minus 4 over x minus 2, which we said was basically, not really, equal to x plus 2. Okay, we said that. So, what's f of 2? So you might say 4, but that's wrong, right? Why is that wrong?
Undefined.
Because it's not defined there, right? You can say not defined, you can say undefined, I guess you could say it does not exist. I don't know. Anyway, let's just say it's not defined. Right? So this is undefined. Okay, everyone agree with that statement? F of 2 is undefined. Now, I'll ask you a new question. Well, not really new, but how about this? Sorry. That. What is that question asking? It's saying about this function, f, as you get closer and closer to 2 from which side?
Right side.
On the right side, what's happening to the height of the graph? Getting closer and closer to 4. Thank you. Okay, everyone agree with that? And if I write this one, so small. What's that? That says if you're getting closer and closer to 2 from the left side, what's that equal to? 4. And how about this? What's that?
Also 4.
Also 4, right? Does this limit exist? Yeah, because I said they have, from the left side, you have to get the same answer as you do from the right side. Then you can say what the answer is. And you do, right? You get 4 here and you get 4 here. Right? So what's the answer? 4. Okay, is that clear? So what that means is this. Do you know what this means? You know what that means in math? No? Suppose I say, well, if the limit as x approaches a from the right of f of x equals the limit then what? Anybody want to finish this or not? If the limit from the left, from the left is the same as the limit from the right, and suppose that they're both equal to, let's call it L. So if they're equal, and they're both equal to L, so that would mean like this case, so this is L, for example. Okay, so if the limit from the right is the same as the limit from the left, and let's suppose that they happen to equal something called L, then what's our conclusion? Can you finish it? Then this limit also will be L, right? So let's write that. Then this limit, what limit again? X approaches A.
From both sides.
Yeah, that means from both sides. It's really hot here, isn't it? Equals L. Okay, do you understand that statement? For those of you that are awake. All right? Now, how about if I try to go in reverse? So, you know, just because if this is true, that means this is true, that doesn't mean the reverse is also a true statement. That is, if this is true, does it mean that these are true? You know what I'm talking about? So, like if I say, if I live in Beppu, then I live in Japan. That's true, right? If you live in Beppu, you live in Japan, right? Now make the reverse statement. Go, if I live in Japan, then I live in Beppu. Is that true? Always? No, right? So just because one way is true doesn't mean the other way is true. Okay? See? But in this case, it is true. Let's check it. What am I saying is true? If this is true, then this is true. Do you agree or not? If the general limit is equal to L, that means that from the left side and the right side you get the same thing, you get L. So if this is true, then this will also be true. Okay? So both directions are true. This means this, and this means that. And when we write that, we use this sentence. We use this in math. So instead of saying if, we write it like that. So that means both directions are true. which isn't necessarily always the case, right? Like we just said, if you live in Beppu, then you definitely live in Japan, but if you live in Japan, you don't definitely live in Beppu, right? But in this case, we see that both directions are true. So this is called an if and only if statement. If and only if. Because if you think about what if and only if means, it means exactly what we just said. Why is it so hot in here? Where's the fan? Fan, okay. All right, do you understand now the basic idea of limits? Because that's basically it. That's the whole deal. Okay, so you might say, well, why did we need to study that? Well, you might also say, why did we need to study this? Right? Well, why do we need to? I don't know. Somebody made us study it. Right? Might be useful somewhere. The same thing here. Hopefully this is going to be useful. Okay, but you don't see exactly where this is useful, and you may not see exactly where this is useful either, right, at the moment. But you will, at least for this one, in this soon. Okay, any questions about that? Okay, now one more thing. We want to talk about what we mean by a function. We want to talk about this. We want to talk about this word called continuous. Okay? And basically all we mean is something like this. This function, now I don't think most people don't want to call that a continuous function. Right? As opposed to maybe this function. You'd be more happy to call that continuous, right? And we just want to get a definition for this. So we can agree, using our eyes, but we want to get some kind of definition that identifies this as well. Okay? So we want to explain why this is not continuous, or why this is continuous. Now, we usually don't say continuous, but continuous at a specific place. So, because you might be happy to say, oh, it's continuous here. So you want to talk about specific places. So, okay, it's continuous here, but most of us would say it's not continuous there. Right? Whatever. Anyway, that's the idea of the word continuous. Now, but we want to get a mathematical definition for that instead of just visually agreeing or disagreeing. Okay? Now let's look at 3 pictures. This one. This one. See if I can remember these 3 pictures here for you. That one. And this one. Those are the 3. Okay? Now if you just look at this one, and let's say at A. This is A, this is A, this is A. So, do you want to say that the first picture, let's call this one. F, G, and H. 3 functions. So do you want to say that F is continuous at A? I think nobody would want to really say that. Okay? So what's your reason? Well, I think the simplest reason is, you might have different reasons, but I think the simplest reason is that it's not even defined at A. Right? This, first of all, just let me ask you, does F of A exist? No, right? This doesn't exist, right? There's no height at A, right? So the first attempt at defining what we mean by continuous at a point A is to say it has to be defined at A, at least, right? That's the minimum requirement, right? If it's not even defined at A, then you're never going to want to call it continuous at A, right? If you're going to have a hole there, that's not continuous. So this one, I wouldn't say is continuous at 2. Okay? I don't think many people would want to say it was. Okay? So we're going to say, first of all, it has to exist at A. But is that enough? Is that enough to coincide with your intuitive notion of continuous? Is that enough? Well, how about G? Does G of A exist or not? Does G of A exist? Yeah, but do you want to call this continuous? No. So just saying that it exists, so 1, F of A must exist. Okay, but that's not enough, because this one, it exists, but I still don't want to call it continuous. Okay? So what I could say here is, how can you identify, what would you say here? What doesn't exist here? In terms of what we've just been talking about. What doesn't exist here? What doesn't exist what we've just been talking about in the last half hour? The limit, oh, by the way, I didn't give you the name. This is called the right-handed limit. This is called the right-handed limit, and this is called the left-handed limit. Okay, and this is, I'm sorry, I didn't tell you this. This is called the general limit. Let me say it again. This one is called, oh, did I do that wrong? This one is called the right-handed limit, and this is called the left-handed limit. So what is the left-handed limit here? Oh, sorry. What is the left-handed limit at A?
Does not exist.
B. And what is the right-handed limit at A? C. Is B equal to C? No. So we say what's this called again? The general limit. We say the general limit doesn't exist. Okay, you agree? The general limit doesn't exist. So, okay, we're trying to define what we mean by continuous. And first of all, we said this one isn't continuous, and I said why? It's not even defined at A. So first of all, we want to insist that it should be defined at A in order to call it continuous. But then I said, is that sufficient? Is that enough? So here, it is defined at A, but I still don't want to call it continuous. So why not? What's wrong with this? The general limit should also exist at A. Okay, so let's write that. 2. The limit, this is the general limit of F, or in this case G, but I'll just write F, should exist. So this should exist and this should exist to be called continuous. But is that enough to satisfy your inner feeling about continuous? Are these two conditions enough? We'll look at this picture. Is F defined at A? Is H defined at A? Or not? Yeah. Let's do this again. Is h defined at A? Yes. Okay, so it satisfies condition 1 for continuity. How about this? Does the limit exist at A? That means if you come in from the left and you come in from the right, you're going to guess the height is the same. Yeah, you do guess the height is the same. So we say the left-hand limit is equal to the right-hand limit, therefore the general limit exists. So it also satisfies condition 2, but do you want to call this continuous at A? I don't think most people want to call that continuous at A. Okay? So we need one more condition, and that is this. The limit should equal that. What is that? Why does that do? Why does that solve our problem? Because if the limit is the same as the actual height, what does that mean? That means this dot actually has to go into here. If we push this dot into here, then what? Then the limit is the same as the height there. And then, I think most of us would be happy to call that continuous. Okay? Do you understand? So if I push this down to there, meaning that the limit is equal to the actual value there, then we call the function continuous at A. So the definition for continuous uses the concept of limit, as you can see. So we say a function is continuous at A if three things. If it exists at A, if the limit exists at A, and if this equals this. So we say if those three conditions are true. Okay, and that's a definition of continuous, and we got to use our concept of limit to define continuous. So I got to make use a little bit of the concept of continuity. Okay? All right, let's look at some of these pictures. Okay, can you read this? The graph of f is given. Use the graph to compute the quantities asked for if a equals 4. Use infinity, minus infinity, these, or dne if it doesn't exist. Okay, so here's the question. What's the limit as x approaches 12? Now a is equal to 4, so this is 4, this is 8, this is 12. It's this height, right? We said a was equal to 4, so it's 4. That clear? So if you got that, good. Okay, now how about this one? What does this mean? What does this mean? As x gets closer to 4 from the right, now a was 4, right? So this is 4. So if we get closer to 4 from the right, what do we guess the height would be? Minus 4, right? Right? So you put in minus 4 here. Okay, is that clear? Okay, now how about this one? What does this notation mean?
On the left.
As you get closer to 4 from the left. So that means this way. Here's 4. Getting closer to 4 from the left. And what does the function approach? Also, negative 4, right? So this would also be negative 4. Now, what does this one mean? This is not the same as this one, right? They're different. So what's the difference between this and this? This is called the general limit, right? Okay, so what's the answer to... So does this one exist? Does this one exist or not?
That's not.
Yes. Why? Because this one was equal to what? -4, and this one was also equal to what? -4, right? Okay? So the right-hand side, right-handed limit was equal to the left-handed limit, therefore we say the general limit exists. That was this theorem over here. Okay? So we can say this is 4, no, sorry, -4, and how about this? F of 4, what's that? What's f of 4? -4? No. What is it? 4 up here, right? 4. So, is this continuous? Why not? Because of condition, doesn't satisfy condition 3. Right? Which is what? The general limit should equal the actual value. The general limit at A should equal the actual value at A. Okay, is that clear? Okay, so what would you say? This, I'm sorry, they didn't ask us that. They didn't ask us if it's continuous, but what would the answer be if they did? No, it's not continuous. Okay, now how about this? I don't know what they want here. Anybody know what they want here? As x goes to infinity, it's really not defined there. But I guess by this arrow, I think by this arrow they mean it keeps going straight up. Okay? So that means, I didn't discuss this actually, but what they're asking is, if you look at this picture, suppose you have this one picture. Suppose we had a picture like this. Suppose this is like the number of people that are going to buy, you're a manufacturer of microphones. You make microphones, and in Beppu, this is, if you keep advertising day after day after day after day, if you keep advertising the number of people that buy your microphones, okay, in Beppu. So what am I suggesting here? That like, if I keep advertising, yeah, I'm going to get increases in the number of people that are going to buy my microphone, but not going to be so much increase. No matter how much I advertise, what am I trying to say here? The maximum is going to be what? 5,000, right? That's what I'm trying to express by drawing this picture, right? So the maximum is 5,000, right? No matter how much I advertise, from this drawing, it looks like the maximum I'm going to get is 5,000 people. So maybe it's not worth advertising after a certain amount, because you don't get much increase in the number of people that are going to buy your microphone. Okay? So, everyone understand that? Understand what I'm talking about? Okay, so if I asked you this, which we didn't discuss yet, but let's call this P, or purchase. Okay, P of X. I didn't explain what this means, but it means that what happens to P as X gets larger and larger and larger? Is there like a highest, is there a number that it's getting closer and closer to? What would you say? Like P here might be 2,500, like here, right? And then P here might be like 3,000. And P here might be like 3,500 and so on, right? And as you get larger and larger, is there a number that p is getting closer and closer to? 5,000, right? So we would write this. The limit as x goes to infinity is 5,000. Okay? Understand? Now how about if I had, let's see if I can come up with a formula for a function that actually does that. How about this formula? Okay, that formula. Okay, that's a function, right? That's a formula, right? Suppose this is purchases, or let's use sales. Right. Instead of P, can I change to S? Changes to S. Okay, so suppose that's sales. And X should actually be advertising, so I could change it to A for advertising, but I'll just leave it as X. Okay? Now, what happens as X, when X is, let me change this to that. Let me just change it like that. So suppose X is equal to 1. Let's say that means $100 or $1,000. So if you spend $1,000, or call that 1, what kind of sales are you getting? So you get 1 here, get 1,000 over 1, which is 1,000. Get 5,000 minus 1,000, you get 4,000 units of sales, right? How about if X is 2? Then what do you get? So this is 1,000 over 2, so what's that? 500, so you get 5,000 minus 500 is what? 4,500, right? Which is more than if X was 1, right? If X was 1, we got 4,000. If X is 2, we get 4,500. If X is 10, what do you get? Then you get 100, you get 4,900, right? So what's happening? This is happening, right? This is happening, right? As X gets bigger and bigger, it gets closer and closer to 5,000. So 5,000 is like we say the limiting value, like the maximum, right? Never going to get higher than 5,000 if sales actually followed this formula. Now, I don't think that anybody's sales ever follows any formula perfectly, and especially maybe not this formula. But if it did, then that would mean that the maximum for this sales would be 5,000. In other words, we would write this. Right? The limit for the sales if X became infinite or super big. What happens to this part when X becomes super big? As X gets bigger, what happens to this part? It gets smaller, right? 1,000 over 1 versus 1,000 over 2. Which one is bigger, 1,000 over 1 or 1,000 over 2? 1,000 over 1. Which one is smaller, 1,000 over 1 or 1,000 over 2? 2. And how about if you increase instead of 2 to 10? Which one is smaller, 1,000 over 2 or 1,000 over 10? 1,000 over 10. And if you go to 100, which one is smaller? So as X gets bigger, what happens to this? It gets smaller and smaller, right? So what happens to this whole thing? We're subtracting less and less from what? From 5,000. So we're getting closer and closer to 5,000. And this, we would say, the limit is 5,000. Okay? Is that clear? For some people, might want to watch this again when I post the video. Some people may not care. Okay. So what's the answer to this? So how about this case though? Is it, according to this arrow, they're not saying that it's ever approaching a single thing, it's just getting bigger and bigger. Okay, that's what they really mean by this. It's not really clear, but that's really what they mean. They just mean it's not getting bigger. It is getting bigger and bigger and bigger and bigger. So the limit doesn't exist. There is no number. Like here, there was a single number, 5,000, that it was getting closer and closer to. But here, I think that what they mean by this arrow is it just keeps going up. So we would say the limit doesn't exist, or sometimes they'll write the limit equals infinity. Now, I'm not sure what they accept in this answer. So they put it in a number. But anyway, okay, let me go on. So let's do this one. How about as A is 1. A is 1. Here's A. So where is -2? It's here, right? Here's -2. So as x gets closer to -2, what's the limit? 1, right? And here's -2. As we get closer to -2, what would we say the height is? This height, which is A, which is 1. Okay? How about this one? -1 is here. From the right, not from the left. From the right, what would you say? 1. But from the left, what would you say? 2, right? From the left, you would say 2. Okay, let's just go on. Okay, so I think, all right, how about this one? What do you think they mean by these two arrows, the blue arrow and the blue arrow? What are they trying to explain to us, or trying to indicate to us? What do you think they mean by this blue arrow and this blue arrow? No? You don't know? Well, I'll tell you. What they mean is it just keeps getting higher and higher. And here it keeps getting higher and higher. Okay? That's what they mean. So what's this? Coming in from the left. Right? Coming in from the left to 0. What would you say? It goes to infinity. That's the answer they want. Infinity. Okay? Or, say, if you want to, if you want to write this, they want you to write it like this. Okay? So the answer to this is infinity, and how about this one? Now this one we didn't really talk about carefully, but I think you might make the right guess. I think you might make the right guess. What? Somebody said, I think somebody said undefined. That sounds like a good guess actually, but I don't think that's what they want here. Undefined. Oh, by the way, I didn't even notice this. Here's a little dot here, right? I forgot to notice that. But anyway, that's not relevant for this question. So I would say undefined is good, but I don't think that's what they want here. But actually, undefined is a good answer. I'm sorry, it is a good answer. But they don't have that as a possibility here. They have DNE. Oh, I'm not sure what they want here. Well, okay, so in math books, they're going to tell you that actually most math books will say this and this are okay. I'm not sure this answer system will allow that. Because when you say infinity, it means that it doesn't exist actually. Because to exist means a finite number. You have to have a finite number that it's approaching. So that's kind of a pain in the neck. that distinction. But anyway, so actually I'm not sure what they're going to ask for here. You'll have to check with the book. Okay? So I would say this or this are both good answers. But I think they want you to say this. Okay. Okay, let's see what else. Okay, let's go on to, all right, I explained what we mean by continuity, but we didn't do that yet. All right. I'm going to skip that. I think we talked about that. I'm not going to go through these problems. Now, I'm going to assign you some homework. Okay. This one. It's really easy to make your life miserable. Watch how easy this is. All I have to do is that. So this is due on January 15th, on June 15th. And not finished. This will also be good. Same day. Now I was kind to you though, because if you check this website, you will see that you can do that you have a chance to do last time's homework again. So you have more chances, and the due date has been extended to June 15th. Because I wanted to go through this in class before I gave you your final chance to do it. So if you check like here, I'll go to Student View, you'll see that this one and this one were due last time, right? But I switched them to June 15th, and I gave you some more chances to answer them as well. You get like 4 more attempts. Okay? So you don't have to do it if you don't want to. If you're satisfied with your score, you can just leave it as it is. But if you want to try it again, you can. Okay, so you can do these or you just leave them as they are. And this one, I'm not going to do this one today, but I am going to talk about this, rates of change. Yeah. I think it chooses your highest score. Yeah, so I think you can't lose by doing it again. Yeah, it chooses your highest score. Okay? That's what it should be. Okay, any questions? Okay, let's go to this. Or let's just take a 3.5 minute break. So let's see, because it's hot in here, we should take a break. So in 3.5 minutes.
Anh giữ này nha. Em chậm đặt như thế. Chị cũng nghĩ chị đặt
Thằng kia giết nó.